Quickly for this video, I don't want to spend too much time on connections for still elements, mostly because they are extremely complicated and tedious, and once you get out of school, you're never going to have to run an analysis on a still connection ever again, because it's just not an effective use of someone's time. Most of the firms that you'll be working for already have predetermined connections for you to use that have already been analyzed, so that you don't have to design a connection every time that you're designing a building, because again, it just takes way too much time and it's just not worth doing different connections for every element in a structure. But I have provided for you just a quick study guide, I guess, or summary of bolted connections that can, just simplifies everything down onto one page of what you really need to remember about analyzing bolted connections. And so for a bolted connection, you're going to have to check a few different limit states. And so we can just go over this really quickly. So first off, you're going to have to check the strength of your elements in tension. And that is exactly the same as what we were doing when we did tension members. You just have to check yielding on the gross and rupture on the net. Now, one thing you have to remember is to check both elements that are being connected. So when we did tension members, if we had our angle or whatever we were looking at, something like that, we were only checking the tensile strength of this member, but you got to remember that this angle is being connected to something else. So for example, it could be connected to this gusset plate right here. And so not only do you have to check yielding on the gross and rupture on the net for your angle, you also need to check it for this plate as well. So you need to check both the elements that are being connected by your bolts. And then next you're going to check for block shear, and this is essentially what happens. Let's just say we've got two elements being connected, and there's like 4 bolts in here. Block shear is when this whole block wants to tear out of this section and pull the whole thing out. So again, you're going to have to check for both of the connecting elements, so block shear on the angle in this case, and then block shear on the gusset plate. And again, that's found in chapter J 4.3, and you use this equation. So first you're going to check this, and then make sure it's less than this. If it's not less than this, then you use that one. And then next you're going to look at bearing and tear out. And again, you're going to have to check this for both of the connecting members like we did in the past. And the thing about this is that these equations are for one individual bolt, and it's going to be different for edge bolts and interior bolts because they have a different LC value. But because these are for individual bolts, you got to take all of your edge bolts and then all of your interior bolts and add all of these together to get a total strength. And then finally, we've got bolt shear, and this is just checking the bolt itself for just, that shearing action on a bolt of it just failing. And you're going to do that by using this equation. And then also in this step, I just like to remember to check the minimum edge distance. But for this bolt shear, this here is going to be the area of the bolt. And this here is going to be your shear stress. And it's an allowable shear stress of the bolt that you're looking at, and that is all tabulated in table J3.2. And really, that's all you need to remember for your analyzing of connections, bolted connections. But as you can see, since you're having to go through and do this for every single element, and there's different minimums and checks, it gets pretty tedious and it takes quite a while. So again, I'm not going to go through a full example. However, if you do have questions with anything that you are working on, feel free to head over to our homework help page, and we'll be able to get you your homework help there.